video, our objective is to improve, to redefine the way we conserve, we restore cultural heritage thanks to the use of the advanced technologies, digital twins, before and today you will learn more about the project with our guests. Before leaving the floor to the experts, let me just remind you one of the ways you can contribute, you can help us shaping our infrastructure, our tools. In fact, we have launched a consultation, a survey. It's a very simple survey. It's just less than 10 minutes to fill it. So for those of you who have not done so already, I invite you to take 5 or 10 minutes to fill it and provide us with your input. It will be very valuable for the development of the project. I'm just pasting, no, maybe I cannot paste a link on the chat. Okay, so we will send you the link of the survey. You will find it anyway on the project website under the main menu. So let me just quickly introduce our two experts of today, starting with Professor Franco Niccolucci, director at the Vast Lab Research Laboratory at PIN in Prato, and president of the Ariadne Research Infrastructure ASBL. In ARTEMIS, Franco is our scientific coordinator. And after that, I'm introducing our second expert, Dr. Anestis Koutsoudis, who is a research director in the Culture and Creative Industry Department of the Institute for Language and Speech Processing of the Athena Research Center. And in ARTEMIS, he's responsible for the piloting activities and will be able to show you some first insights of the work we are carrying out in the project. So, Franco, the floor is yours, and have a nice webinar to everyone.
Okay, thank you. So after the introduction, I can go directly to my presentation. Let me recap what Claudio just said. ARTEMIS is an EU-funded project having as objective to unlock the full potential of a full-fledged digital twin approach to support and improve research and practice in conservation, restoration, safeguard, and valorization of cultural heritage. It will have a duration of 3 years with a very wide partnership and excellent partnership, I should say, coming from 8 European countries. And they are a mixed combination of research, data and research infrastructures, and enterprises, small, medium enterprises, with also a wide range of expertise in data management, semantic organization, heritage science, which is necessary for the scientific component of our project, and 3D modeling and AR and VR. It relies on a vast amount of heritage data, which are provided by Ariadne, by a Belgian DigiLab, and by the British HSDS. So altogether, the project can rely on 5 million heritage-related datasets. At this point, probably you will wonder, what does all this mean? And so let me give you a trailer of the project. Just a moment. So another video.
There are things we cannot afford to lose. The carved face of time, the glow of a fresco at dawn, the silence of a palace that has seen centuries pass. Our cultural heritage is alive. It breathes. It changes. It suffers. And today, it can react. Welcome to ARTEMIS. For years, we've created digital copies of reality, images, models, archives. But now, something has changed. With ARTEMIS, we give our heritage a new kind of presence. A reactive heritage digital twin. A digital replica of a real-world heritage asset, incorporating all the data about it, which can interact in real time with its real counterpart to exchange. But how will these digital twins actually be used? Imagine a storm approaches. The reactive digital twin gathers real-time environmental data. It simulates the impact, identifies risks, and tells us where to act before the damage occurs. In this case, the reactive digital twin sends a signal to raise the painting off the wall. A flood risk has been detected. The system prepares just in time. Sometimes danger is invisible, like humidity slowly seeping into walls, wood, and paint, or atmospheric pollution, silent, corrosive, and constant. We can't see it, but the reactive twin can. It detects rising moisture levels, maps how it spreads, and warns us before irreversible damage begins. It's like giving heritage the ability to feel and to ask for help. And what if we could test a restoration before ever touching the original? See the results, explore alternatives, improve the plan. All inside the reactive digital twin. Safe, reversible, precise. Protecting heritage means combining science, art, and technology. It means acting across borders, disciplines, generations. Behind every reactive digital twin, there's an immense volume of data, environmental readings, material analysis, historical records. The Reactive Heritage Digital Twin relies on a vast digital library of information about objects, materials, scientific analyses, and also about the intangible values of heritage. This is ARTEMIS. Digital technology stewarded by human intelligence and supported by Reactive Heritage Digital Twin. There are things we cannot. There are things we.
Okay, so I think that this video gave an idea of what the project is about. Because the objective is to avail of advanced models to replace physical experiments and interventions by digital objects which reproduce the features and effects, the features of the artifact and the effects of the intervention. This corresponds to the creation of digital models which represent physical objects and are capable of mimic their physical counterparts in real time and to simulate the effects of actions. The project will thus directly benefit professionals in conservation and restoration because it will support informed decisions and will open new opportunities to valorize heritage assets. So there are three main aspects to be considered, and that is the data, because to operate we need to have a very large amount of data, all fair, in an overarching but flexible framework. So we need to overcome the fragmentation of data repositories, and we start, as I already mentioned, from two large national scale repositories, NAU data infrastructure. Then we need models, so we need to model the behavior of heritage assets according to simulated actions to obtain a correspondence between the simulated effects and the corresponding results when they are carried out in the real world. And third, we need the services which enable all these activities, providing storage, organizing the data, and then making possible to search and retrieve the required data for the intended purposes, with the user interface comfortable for the user. A fourth, but not less important aspect is people. As it has already been mentioned, this development must be community-driven. So it will not be a mere technological implementation, because it will need to address the real problems of the cultural heritage community. By the way, we have two important conservation laboratories and restoration laboratories in our consortium as associate partners. And of course, dissemination and training, like today's meeting, are important components of the preparatory work to enable professionals to avail of the project results. So, just to explain what is this digital twin, I have prepared just two examples. The digital twin of an amplifier system in a room includes data about its design, content, and use, alarm levels. So when the sensors warn that there is a risk of fire, and then which are the fire extinguishing devices, water sprinklers, or azote for azote diffusers, which can combat efficiently the fire. Of course, the room content may change in time, and these changes need to be reported in the information about the room content, and in this way, the data will always be a faithful representation of the actual thing. The digital twin in this case is connected via sensors, that is, devices that measure the values of the relevant physical characteristics and transmit them to the digital twin. So the digital twin is continually informed of what is happening in the room, and it continually compares with the alarm level. And if, according to the results, there is a risk of fire, it activates the anti-fire device appropriate to the current room situation and use. For example, water or azote if the content does not allow using water. So it is a sophisticated version of automatic system, but which is much more intelligent than them. Another possible. Okay, let me see if okay. Another possible use of digital twins is for the simulation. In this case, in this example, there is a building where the information about all the relevant values is kept, is stored, like construction system, shape, foundations, and so on. And so it is an accurate replica of the actual building and its structure. Any change in the building is regularly recorded. There will be no frequent changes in this case, probably, as it also happens with cultural heritage, which changes very slowly in time. An earthquake simulation consists in producing a replica of the forces that an earthquake will produce on the building and their effects on it. This may help in designing appropriate changes to pillars, walls, and prevent the damages or the destruction of the building. It can also be used to test escape ways from the building. The term digital twins is a buzzword, and we took advantage of this its popularity. But unfortunately, there are also some misconceptions. Typical, the statement here in italic is a typical misconception. A digital twin is a 3D model, 4D model, virtual reality, augmented reality, BIM model of a physical object, and on its parts there is attached the digital documentation of the corresponding part in the real object. In the picture you see there is a pyramid and stickers which represent the information about the different parts. This is not a digital twin because it doesn't work for everything. It relies completely on 3D models, which are an important part almost always for digital twins, but in this case, they do not work for shapeless or changing objects, for example, liquids, rivers, gardens, and so on, and for immaterial objects like traditional music, which are an important component of the cultural heritage concept. It is lossy, and you can see in the picture that some stickers are on the ground and are no more on the object, because if the attach point is removed or changed in the transformation of 3D model, you may detach it unadvantagely. For example, if for some reason there is a decimation of the 3D model to reduce its size. It is also unusable for cross searches on different models. For example, searching across different assets, all the objects with parts made in wood to make the best and collect the information about such kind of material used in the buildings. But since the information is relevant for just one object is attached to it, there is no cross connection between different heritage assets. And last but not least, it is not usable for simulations. So we created a different concept. We did not create, we proposed a different context, which is the heritage digital twin, so far without R. So only a data organization. And such a digital twin is the complex of data that reproduce in digital format the knowledge about a real-world asset, together with software functionalities, which enable processing. And this means that such data can be modified according to changes in the real world, either for update or changes that may impact on the object, typically via sensors. Otherwise, the changes are not real, but they correspond to hypothesized changes. So it is a simulation, testing what if would happen, what will happen if there are operations made on the asset. And then there are connections with the real world, which implement intuitive effect of changes occurred to the digital twin data. This is typical the case of sensors, like in the fire example, the actuators started the operations of the anti-fire system, water sprinklers, and so on. These changes are executed automatically and with a regular schedule, subject to automatic decision rules, which may avail of artificial intelligence use. Many of these changes can be not dangerous, and so there is just an update, or if dangerous, some particular action is implemented. Or they can be implemented, the changes can be implemented when requested by a human operator. This is typical of simulations, but also in cases in which no automatic action is sufficient to prevent or to mitigate the risk of damage. For example, there are some kind of fires, fire of a forest, there is no sprinkler that can fight it. So there are messages to the fire brigade and the use of Canadair and so on. So in some cases, it is also when there is a feedback in the world, it is possible that no automatic reaction is sufficient to fight. The most typical case is anyway the simulation, and simulated experiments. One can see in the digital twin what would be the effect without making the actual simulation, implementing the actual activity. So the heritage digital twin may be defined as the holistic complex of information about the heritage asset, the twins. Such pieces of information are related to each other. For example, a digital photo is related to a specific digital asset, the one it represents. Documentation relates to one or more assets. A book on history of architecture may refer to many of architectural monuments. One important advantage is that our data organization is a compatible extension of a standard, which is very, very much used in the cultural heritage domain. And so its data of our system are interoperable with data repositories which use the same standard, the standard of a compatible or a compatible one. An example is Europeana, which uses EDM, which is a compatible system compliant with the standard. So in practice, almost all the cultural heritage ones, because the data about cultural heritage are almost everywhere organized according to the standard or to other compatible data organization. This is the case of the heritage digital twin. So the system of the heritage digital twin is actually what is called an ontology. That is a system that organizes the knowledge contained in the digital twins. It consists of classes that is type of data, actually metadata. So, for example, buildings, it contains monuments, historic palaces, houses, and whatever. And then these data are related with each other by properties. So we can draw a picture like the one in this figure, where these small things, you cannot read them, but these small things here are sets of similar objects, and this line connects to each other this information. So this is a way to organize the information in a graph, and altogether, the data organization and the content that is the actual data form the system's knowledge base. One could expect that to organize all the data concerning cultural heritage would need a monster computer. This is not the case because the data will remain where they are. They will just be aggregated. That is, ARTEMIS will manage only their metadata, and the data will remain in the capacity and in the property of their owners. The only condition is that the data are fair, that is findable because you need to find them, accessible because to get information you need to access them, interoperable, that is organized according to the standard or to a compatible system, or to a system compatible with the standard, and reusable, so there must be no restrictions to use them again. So how will this work? The users will interrogate ARTEMIS knowledge base via an interface through which they will receive the information contained in the digital twins. So there will be an interface where the user can set some search parameters and retrieve all the data that correspond to such parameters. Typically, it's a typical form where you write what kind of things are of your interest, and then you get a list of the results. We are also going to experiment natural language requests like tell me all the 16th century churches which have wood in their roof, and the system will translate this into a precise query and provide you with the results, accessing them throughout the participating data repositories, which are present are only the 3, even if they are very large ones, but we expect that it is going to increase in time. So already this is a big advantage because it is a rich data aggregator which can be used in study and research. It enables collecting information on objects, on heritage objects, and on previous interventions of similar objects, which is the basis of the simulation of restoration activities. If one is going to operate on some wood artifact, it may be interesting to see what other similar interventions on wood artifacts have been done and what was the outcome. Thus, they enable simulation, simulating in VR the results of activities on heritage assets. Last but not least, but this is not part of the project, but it is a byproduct, all the information will be stored in the same place with rich content such as images, 3D models, but also stories and traditions. And so it will be a system which may help in creating tools to valorize heritage. So let's see what there is an R which was not explained so far. Let me go dynamic. The heritage digital twin concept is extended into a reactive one. This is an extension which enables to manage data concerning cultural heritage and take into account the possibility of activating reactions via actuators, but in reality of simulating such reactions by experimenting them on the digital twin. So, for example, if you paint in red a wood object, what will be the resulting color? Red or some maroon color because the wood reacts differently. Before painting the actual object, you may try it virtually and see what is the results. An image is worth 1,000 words, so seeing it concretely may help in avoiding mistakes or damages. The system is also designed to include data concerning heritage science analysis activities. This is an example of an XRF. Those of you with some familiarity in heritage science will know what it means. It is used to find out which are the material composing an object. And I think that in this case there was a manganese, copper, lead, and so on. So there are many of these activities, and we will incorporate them in the knowledge base as regard the results, but also enabling access when simulation is carried out. And so the system, well, has 4 elements. If it is just a reactive system, sensor, decider, and actuator. For example, it may take autonomous decisions. There is an object placed in a church, too much humidity, it risks damage, and the system can start ventilator to reduce the value of the such humidity. Most interesting is the simulator. It will operate on a local duplicate, so it is expected that the user, the operator, downloads a digital twin of an object. it simulates on this digital twin all the activities, looks at the effects, and if they are not interesting, it is duplicated, discarded, but more often it will be saved locally to keep record of what happens when starting this kind of work, painting or using or doing other interventions on the object. So the goal, the main goal, and the thing because the project is funded, is this kind of simulation. How will it work? Every simulation will create a local version of the data required for the simulation. So if I start and ask, I want to simulate the restoration of this painting in this and this way, the digital twin of this object which I'm going to simulate will be duplicated, of course, to avoid intervening on the real digital twin, but also because all the processing work should be done locally. Otherwise, there will be big amount of data going in and out across Europe, because probably this information will be displayed in distinct repositories. We expect that it requires very large data sets like 3D models, advanced reality data, and so on. So this is transferred once for all in the computer where the simulation is going to be done. This is also a technical framework which is called Edge, and the Edge nodes will probably, in our case, will correspond to local computers to allow with quick interaction with the AR devices, avoiding the delay caused by the download of a large amount of data. Imagine what would happen if you have to wait until 1 terabyte of data is moved from the various depositories to your local computer, and you can understand why this is important. If there is a need for additional data, and only in this case, they will be downloaded on demand. So this image, imagine you are here. This is the edge node, and this is the cloud which collects the data from various repositories here. The edge node can be a local computer to which you are connected, for example, a server in your university or research centers, or can even be your laptop. Nowadays, there are powerful laptops where you can do all the work concerning AR and VR. Data will come from here to here once for all, and then you can work on that, perhaps also with colleagues if this is stored in a shared local server. So what is the perspective, the 3-year perspective? To use the information stored in the reactive digital twin to simulate activities on a heritage asset, testing the results of such activities by performing them virtually on a digital twin. This result requires availability of visual information on the asset and on its components. We will explain the conditions necessary to carry out the simulation, indicating the required data and tools to process them, and paving the way for further developments. And it will be supported by VR technology, visualizing the effects of simulated activities. The last point is not an essential one, but it helps work because it visually shows what happens in the simulated conditions. It is possible that the required data will not be available during the project. In my experience, with the Ariadne experience, we have seen a massive increment of the available data during the project. So people and centers which have data stored somewhere may associate to this system later on during the project or even afterwards. And it is a sort of avalanche process when the difficulty in the beginning, but then when people understand that being associated allows participating and adding their contribution to a very promising system, they will do that. And what do we expect from the project? Well, at least what we promised to the European Commission to be the project outcome. The design of the workflow necessary to aggregate repositories of data concerning heritage assets, organized according to the Heritage Digital Twin paradigm, and the design and initial setup of such knowledge base within a cloud environment using the currently available data. Also, to how to extend this knowledge base by incorporating in it more data set. So the use to contribute and the way the workflow enabling such extension. A deeper understanding of the tools required to elaborate the relevant data to simulate activities on the real asset and to provide guidance for its conservation and restoration, including the demonstration of the court procedure with selected pilots. So at the end of the 3 years, we will have a well-designed system which needs growing more as regards the data and as regards the services, but which will prove its importance via selected pilots. And the king of the production of these pilots is my colleague Anestis, who will speak after me and show how this, how we think it will work. And all this will proceed with the involvement of the communities, which will be the future users. And of course, we need their support, advice, and confirmation that we are on the good path. And so this is the future we prepare. You already have seen this image where the scientist studies this skull, not on the real object here, but on a digital copy here, and using a visor for augmented reality. Okay, that's all. And thank you for your attention. And I leave the floor to the organizers and to Anestis.
Thank you, Franco, so much. Let me just inform you that first, thanks, Brian, for pasting in the chat the link to the survey I mentioned above. If you have any questions, you can use, if you are connected via Zoom, you can use the feature, the question and answer feature of Zoom. Please feel free to enter there your question. We will read all the questions at the end after Anestis' speech. You can also, for those who are connected via YouTube, we have a high number of participants via YouTube as well. Feel free to ask questions there as well, and we will report them at the end. But I do not take more time, and I leave the floor to Anestis, who can tell us a little bit more how we can implement all these concept and methodological approach Franco just presented into concrete cases through the piloting activities of the project.
Thank you, Claudio. I think you can see my screen by now.
Yes,
right.
We can see it
as well. So within the ARTEMIS project, we are looking at pilots as a way to demonstrate the way a reactive heritage digital twin concept can help professionals in the cultural heritage domain. So we define the term pilot in Artemis as a real-world experiment designed to validate one or more of the technologies that will be available through the Artemis framework against specific cultural heritage scenarios. So a pilot revolves around one or more heritage assets, movable or immovable, tangible or intangible sites, structures, or collections, and it actually articulates a concise set of objectives. Together, followed those objectives with a number of measurable success criteria. So in order to define the purpose of the pilots that are going to be implemented within the Artemis projects, we have defined a set of primary tasks. Those tasks are going to demonstrate how the Artemis technologies are going to be used and set the reactive heritage digital twin into service. These tasks, the main ones, the primary ones that we have currently identified, is the utilization of virtual reality, augmented reality, or extended reality technologies to create a collaborative environment where virtual activities and experimentation can take place. As Franco mentioned, one of the backbones of Artemis technologies is the simulation. There, we will try to test the effects of processes that are either natural or anthropogenic on the digital replicas of the assets, while we will be focusing on mimicking, let's say, the natural behaviors of researchers in a laboratory. Again, through the introduction of Internet of Cultural Things, sensor networks, we will be able to construct some decision support systems that will be based on real-time monitoring and receiving of real-time data over these sensor networks in order to provide either early alerts and react by responding according to the situation that the system is understanding given the details or the data provided by the network. Again, a dynamic interaction with spatially and temporarily mapped, allocated, multi-layered information on a 3D digital replica or various 3D digital replicas which somehow depict an asset, a cultural heritage asset, through time. In order to ensure within the project the consistency and clarity across the various Artemis projects, we decided to adopt a structured design template, a framework that is composed by 8 sections. Those are being briefly listed in the slide we are currently seeing, and it attempts to capture the full life cycle of its pilot, from its initial case study to its final validation. It offers the consortium of the project a systematic way, let's say, that will allow us to define the goals, the resources, the methods, and the expected outcomes of each one of those pilots. Furthermore, we also currently working on a rapid reference tool. It's called the Pilot Features Checklist. And through this checklist, we are trying to, while we're designing each of the pilots, we are making an efficient way to monitor what are the sets of the technical features that each pilot will offer. Will offer to the end users, which are considered to be professionals in the cultural heritage domain. So we start by identifying simply the scale of the cultural heritage asset, or the assets that the pilot will be focused on. We see in terms of methodology and simulation the various capabilities that will be demonstrated by each one of the pilots, what simulators are going to be used, what is the result obtained by each of these simulators. Can this result be visualized as a 3D animation, or is it a novel 3D state of the initial 3D digital asset? Is it a graph? Is it a sequence of graphs? It might even be just a number. So all of this information are currently being somehow incorporated in this checklist as a rapid reference tool. Furthermore, we are also interested in what the pilot will offer in terms of user experience and data handling, of course. So we are designing the pilot, so we also attempt to address both tangible and intangible, the intangible and tangible dimensions of its cultural heritage asset. Through this way, we hope that we will be able to provide a diverse and, let's say, realistic list of use cases that reflects the richness and the complexity of the cultural heritage domain. As part of the pilot's design process in Artemis, it's inevitably the process of identifying who we are designing for. The primary users and stakeholders who will interact with the platform and benefit from it, or can even contribute for each of the one of the pilots that we are going to implement. Here we present a preliminary group of those target audiences based on actually the diversity of the roles we have identified in all those proposed pilot ideas by the Artemis consortium. So at the moment, we are aiming at 4 main target users. The first one is focused on the cultural heritage management in practice. The second one focuses on research and academia, then move on to public authorities and policy makers, followed by technology and infrastructure stakeholders. The pilot objectives. Again, our current efforts allow us to thematically group our pilot ideas based on those core objectives, which are, again, organized in 4 main groups. It's the condition monitoring and simulation, which one can think of it as a number of use cases focusing on utilizing sensors and simulations to understand and anticipate any environmental, structural, or material changes to a cultural heritage asset. Then we move on to collaborative knowledge sharing, where pilots that build shared workspaces, or let's say platform for professionals such as curators, restorers, or researchers, where they will be able to annotate, assess, and co-work on a cultural heritage content on a movable or an immovable asset. Furthermore, in relation to visualization and interpretation, there is a group of pilots that aims to offer enhanced access or engagement with cultural heritage digital replicas through an augmented reality or virtual reality or extended reality approach, or even through visual storytelling, offering new methods and, let's say, new approaches of how one could interpret heritage assets and how process information relevant to them. Last but not least, the reassembly and reconstruction targets through the application of reassembling fragmented artifacts and providing digital reconstruction solutions of damaged or incomplete heritage asset by utilizing 3D computer graphics technologies and other semantic tools. Behind each of the Artemis pilot ideas, there is a set of key technologies. So each pilot that will be implemented within the framework of Artemis is actually supported by a range of complementary technologies that are put to work all together to deliver the reactive heritage digital twin concept in practice. These technologies, as you can see in the graph, currently spawn across three main categories. This is the user-facing functionalities, this size of the graph, followed by the integration and infrastructure technologies. And then it is the semantic knowledge systems forming altogether, let's say, the backbone of a pilot's implementation. At the moment, while we are still working on identifying which are going to be the pilots that are going to be implemented within Artemis, we have already identified a list with a number of assets that are linked to specific pilots' ideas. This list, of course, will be further refined as the project progresses. Here you can see the allocation of the various cultural heritage assets as being currently being identified by the pilot's ideas. But let's move on to something which is a bit more eye candy, and let's have some sneak preview of some of our very early implementation results. I'm going to show you one of the tools that we are actually developing from scratch within the Artemis projects. It is an annotation environment prototype that utilizes XR headsets and enables an immersive interaction with digital representation of the heritage assets. The tool is going to be designed, or it is designed and further be updated to also support collaborative analysis and interaction. So multiple users can be joined in this XR environment and use this versatile platform to either implement different types of annotations, multimodal annotations, be able to see data streams from various Internet of Things sensors, can perform various operations, including spatial measurements, distances between different points, but also to set up scenarios that will be referring to specific simulators. For example, the crowd movement, which is also going to demonstrate today. Of course, the XR environment can also allow users to visualize and assess these simulation outcomes in a real-time 3D space where collaboration and discussion between the people involved can be implemented in the same way as it could be done in a laboratory. So we are hoping that this environment prototype will represent a foundational step in, let's say, linking immersive interaction, sensor intelligence, and simulation workflows for some of the Artemis pilots. Here is a video of a very currently work in progress of this annotation system, where a user has at his side a panel that enables the user to let's say, access all of the available functionalities in the 3D space. One of these functionalities that we are currently working on is the ability to annotate a 3D model.
Fire alarm sensor.
The annotation can be implemented towards a specific point of interest.
Fire alarm sensor.
Or an area around the surface of the object, or even enclose an area of the model within a geometrical primitive, like a cube, a box, a sphere, or a cylinder, And then by utilizing speech-to-text or other GUI solutions, such as gesture-based command, voice-based commands, or even VR air-based can annotate various parts of the model according to the use or the scenario that the digital replica or the digital reactive twin is being used. One of the steps that we are going to add within the next two months within this environment is the ability to have an actual web browser and all its functionality on the user panel that follows each one of the users as a way, as a method to actually communicate this virtual reality environment with the set of microservices that are going to implement within the ARTEMIS infrastructure and allow us to move data bidirectionally towards the knowledge base. So as the video moves on, we can see that the user is actually using a virtual reality keyboard and typing in just like he's holding, let's say, a tablet or a mobile device, some textual information that can be allocated.
Central entrance with rounded brick archway.
Can be allocated to a specific part of the building. There are, at the moment, we have implemented 6 types of annotations, including the one that allow us to perform measurements on the 3D model. Here, again, the video demonstrates how this can be implemented. Remember that still is a work in progress, and we're still having to make a lot of effort to identify what is going to be the best human-computer interaction approach in order to have this annotator operate efficiently within the XR environment. The reason you are currently watching a black background, it
building height
has to do with the specific headset we are using and the GDPR laws that it doesn't allow us to record the actual environment where the user is currently in. So you can see it at the very left right top corner of the video what the user is actually been doing. So bringing in the idea of the web browser functionality and connecting this system with the VR/AR microservices, we will allow us to be able to connect point of interest with other information, much more complicated than simple text annotation. And we can link these points of interest with metadata, paradata, and of course we can semantically link information from the knowledge base and thus enabling
Manos Hatzidakis residence 19th century mansion.
Enabling the annotation of specific part with references to historical data, conservation records, ontological entities, or related documentation. So here you can see an application of the primitive based annotation, where this is a 3D model of the historic center of the city of Xanthi in Greece. And the building that the user was previously annotating at the close-up level, it's now annotating its position within the whole historic center. Maybe I move the video a bit faster. So imagine that we are trying to set up a scenario about an event that will, let's say, take place in the old town of Xanthi in a central plaza, the one you see now that the user is pointing at its green pointer. So we want to set up, let's say, for this crowd movement simulation, we want to set up the places where crowd metal barriers will be placed in order to somehow control the way visitors are allowed to move during this event, let's say this music event. So the user can actually set up this scenario by utilizing the entity-based annotation and by selecting through a large set of predefined 3D assets, place those metal barriers on the roads that are supposed to be to restrict, let's say, the crowd to move in those streets. And in one way or another, he will be able to interactively create the properties or the scenario of a crowd movement simulation. So here you can see him utilizing the create entity annotation, which can also be an icon. Apart from a 3D object, it can also be an icon that somehow represents some context that can be assigned to a 3D model. Here we have, let's say, high voltage cables, or here there are some other type of sensor, or this is a public building, this is a school, and if something happens during the day, where there's still children in the school, this is the first priority during an evacuation scenario. So, more or less, this is a current state of our XR annotator, and let's move a bit forward. Some other commands is like you can use voice commands to enable or disable parts of the annotations or specific parts of the annotations. So it's a combination of different ways of interacting with the system in order for the user to identify what is the best way for him or her to use this annotation tool in the extended reality environment. Let's go now and see a few things about simulation. METIS is a crowd simulator that Athena Research Center had developed within the framework of another project, and now we're moving a bit forward on this crowd simulator to adapt it in order to be utilized within the ARTEMIS and focus within the cultural heritage domain, as the initial scope of this tool was to focus on crisis management. The technologies behind this simulator, it's that it's agent-based, and avatars can have roles and responsibilities, so they can simulate both physical and psychological aspects. And this simulator can be a part of a decision support system that could affect or provide some effort on creating efficient evacuation plans. It supports both indoor and outdoor environments. It's been implemented on a game-based solution, so avatars have natural animation, and disasters like fire do have a physical and realistic visualization. It is able to offer a scalable number of agents, and it is implemented in a dynamic and interactive environment, so users can actually use this environment to set up the scenarios. As I said, currently we are moving on adapting we are moving our implementation efforts in order to adapt this tool and use it as a service oriented solution that is going to be using a REST API, as most of the other services that are going to be implemented within the ARTEMIS project, and allow users to address to this simulator through simple JSON, technical here, JSON commands, where a simulation experiment can be offered as a request. Now, in relation to the cultural heritage focus and all the adaptability we are trying to implement to this simulator, of course, we are trying to simulate non-emergency situations. For example, individuals moving in a museum, individuals moving in a building, or an archaeological site. And we're trying to identify specific risks or negative impacts that can be caused by the crowd behavior. For example, you have a mosaic in an archaeological site, and visitors are actually allowed to move, to walk over this mosaic. So with a simulator, we can create, let's say, a heat map that somehow plays the role of indicating what are the parts of the mosaic that are going to be affected by having the people walking on it. Of course, we are also trying to adapt the system so it will offer us a real-time per-person analytics, so we can aiming to be able to deliver from each one of the point of view of each one of the avatars that is currently be involved in the simulation. An avatar will be also enriched in terms of properties with a mood status and other interaction that could be implemented with the environment. So more or less, we're trying to move from what was shown in this small window video to something that is more applicable to the cultural heritage domain. And I will finish my presentation by saying that a crowd simulator can be utilized to give us answer to both logical but also to wild questions. For example, one wild question could be if we can fit 400,000 people at the same time in the historic center of Xanthi of Greece. Well, the answer is probably yes, for what the video is actually showing now, but someone relevant to, let's say, to citizens' security is more appropriate to discuss of whether this situation is something that we should consider happening or not. And so with this video, I finished my presentation. Thank you for your attention.
Thank you. Thank you, Anestis. Thank you, Franco. I hope we now know more about the project, about what we are doing, what we plan to do in the near future. If there is any question, feel free to ask them, to add them. We now have a few minutes for questions before closing the webinar.
I have a very quick comment for Anestis.
Yes.
It seems that you read the newspapers, because they today report big manifestations against over-tourism there. So I don't think the Xanthi has over-tourism problem. Probably you have, but Barcelona, Florence, and Venice do have. So that would be something which is relevant. Just understand how people move there and the damage they can do in the open, but also within museums, because there are cases of overcrowded museums where a few days ago somebody broke a chair in a museum, artwork in a museum. So it's something that shows an immediate utility for preserve in general, and in particular for artifacts. The Mona Lisa portrait is also another example of overcrowding in a museum.
Always.
Yeah.
It's always like that.
That's very appropriate.
Yeah. Well, Xanthi has actually this problem a very specific week every year. The last week of September, the last week of August, and the first week of September, where this all
so we will avoid organizing a meeting in Xanthi in those weeks.
That's why I'm saying it. That's why I'm bringing on the table.
So in the meantime, I can take a couple of questions that we collected through our channels. So there is one about artificial intelligence, whether there is any plan to include AI in the ARTEMIS infrastructure and services, and if in such a case, how?
Well, I can answer because we already have made some very interesting experiments. As I said in my presentation, there is a need of a huge amount of documentation. The more, the better, because more documents you have and more information you have, and you can make better models of the real world. But unfortunately, these are usually papers, texts, and stored somewhere. We hope that they will be stored in a fair way, but searching them is not easy nor practical. So we are testing, and we will give a short demo in the next week of how it can work using large language models. Of course, to extract metadata from unstructured text. And this is the first example. And it seems to work. It seems to work. The AI software which we are going to use is not ChatGPT, but it is an open source software, so everybody can check and verify that there is no hidden mechanism inside. Of course, there is it has to be tested to avoid hallucinations. I can quote an interesting example. This service was used for the restoration of a painting by Botticelli, which is exposed in the Uffizi Museum. And this painting was brought to a laboratory, to a restoration laboratory, to be restored. And the system attributed to the painting that it was exposed in this laboratory, which is not the case. So there are still some, I would say, ingenuity, not hallucination, something which the system cannot manage, so what we will work on that. The other case where we are going to introduce artificial intelligence for accessing the data is natural language questions. So instead of typing into a form things, the system is created to ask questions, not yet by voice, but this is an easy step, but just typing a question as you would type in Google or wherever, or ask Siri or Alexa or whatever. So two ways: improve metadata by processing documents which are not well organized, and of course there is a need of checking the results because some mistake is still possible, but it can be learning by errors, so you can correct it and improve the system, and natural language queries to search the system.
Thank you, Franco. We have maybe time for one last question. Maybe this is for more for Anestis. Is whether ARTEMIS can be used with my existing monitoring systems. Whether it will be possible to take data from these systems and reuse it for modeling scenarios, and what kind of requirements, what sort of data is needed for making simulations and evaluations.
Yes, I'll start with the simulation way, which was the last part of the question. So for each one of the simulators, we are aiming at defining a REST API that could be addressed through the ARTEMIS infrastructure, and based on what are the prerequisites of the simulator in terms of data or in the terms of how the scenario is going to be implemented. Those are going to be described as guidelines of how one could access this kind of technologies. The rest of the infrastructure, I might not be the best person to answer that in the consortium, but as far as I can understand, all of the services will be made available through the project, and people will be able to identify pilots that somehow meet the needs of their use cases and use this information available by each one of these pilots in order to identify the ways of utilizing the ARTEMIS infrastructure.
Thanks,
Yeah,
Anestis.
And if I may quickly add, Claudio,
yes,
just
sure.
ask. So if you have an idea, just ask, say, write to us, and we will consider. Probably we are not ready for that, but we will consider that in the design and development, and possibly to incorporate it also in the project outcomes.
Yeah, and another way to do this is through our survey. Actually, in the survey that we designed, there is a specific sections where you can actually propose something, describe the data that you have available, and give us your availability to test our systems and become part of ARTEMIS experimentation. So once again, please take 5 minutes and fill out our survey to help us and to cooperate with us. So thanks so much. Thank you, Franco, Anestis, Ginevra, Brian. Thanks, everyone. And let's stay in touch. Please follow us, follow our project, our social channels. You will hear more about us. We're planning a second webinar soon. You will know soon about the date of the second webinar. And have a nice day and see you soon.
Thank you. Thank you, Claudio.
Bye-bye.
Bye, everyone.